Let's now take a look at the distance between two complex numbers and then take a look at some inequalities as well. I think that representing this geometrically, I mean with diagrams, makes it much easier to understand. The first one is very simple. If z is a plus b I, so this point over here, and w is c plus d I, this point over here, then the distance between them, which is represented here in blue, is given by what? Just take a look at this. This will always be the hypotenuse of a rectangle triangle that has the other sides as being the difference between the complex part and the imaginary part. As such, then the distance is going just to be the square root of this side, which is a minus c squared, plus b minus d squared. I'm just applying Pythagoras over here. This is valid for whichever two complex numbers, wherever they might be. You can always make a rectangle triangle out of that, and the distance is going to be the hypotenuse of the difference between the real parts and the imaginary parts. Okay? What if you have inequalities? Let's say that you have something like this, in which r is a known value. What are you actually trying to figure out? The first one is not an inequality, obviously. This is basically just the distance between the distance to a generic point a plus b I. That's what you have over there, right? So if we're saying that this has a specific value r, then what are we saying? We are saying that the distance can be from this point a plus b I, can be this one over here, can be over here, can be over here, can be over here, can be over here. What we are saying is that the distance to this generic point has always the same value r. All right? Whatever it is, this may be, for example, 3. If the distance to point a plus by is always 3, the position of that point may be here, 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 here. Basically, it's going to be just a circle with a center on the complex number a plus bi. Make sense? Now, if instead you have an inequality, what are you saying? If you are saying that the distance is smaller than r, then we are talking about, I don't know if you can see, yes you can, I think. It's going to be this yellow part inside the circle. All of this, any point inside the circle, is smaller than r. Conversely, if you have bigger than r, then we are talking of any other point that is outside of the circle, the orange part over here. Okay? What if we have this? Z minus a plus bi is smaller or equal to z minus c plus di. As in the first example, I want you first to think of the situation in which this is an equal. What are we saying? This is a distance to a point A, and this is a distance to a point B, as we saw before, right? So if we're saying that they are equal, this must be a line that is exactly in the middle of the line connecting A to B, and perpendicular to it would be this blue line over here. Any point on this blue line is at the same distance from A and from B. If you understand this, then this would be simpler, okay? If you're saying that it's smaller or equal, so you are saying that any point would be closer to A than to B. So it would be this line here represented in light blue plus the full line over here, because here I have the equal. I didn't bother to put any other situations like without the equal or bigger than, because you already know that then it would reflect to the other side. If you understand this, you understand any other possible variation.